Hi dear students, in our last session we discussed the introduction about the chapter of rational numbers. So today in our section let us study the new exercise 1A. So dear students, last day we studied about the introduction part of the chapter rational numbers. Today we are going to practice some questions, okay, by the basics which we have received from the previous class. Let us go with the first question. Here goes the very first question before you. Express minus 3 by 5 as a rational number with the denominator minus 30. So here you can see a rational number is given. It is minus 3 by 5. And what is the question? You have to express this minus 3 by 5 into another fraction, that means into a rational number which is having its denominator minus 30. Now check out the denominator and numerator of the question itself. Here the numerator is minus 3 and the denominator is 5. Okay, we have to make this 5 as minus 30. Tell me, by what number should we multiply 5 so that we will get minus 30? Okay, keep that minus there. By what number we should multiply the denominator so that this will become 30? That is 6, right? Because it is 5 here, the denominator is 5. We know 5 into 6 is 30. We want minus 30. So 5 into minus 6 it will be, right? It is minus 6. So if you are multiplying the denominator by minus 6, definitely the denominator will become minus 30. So already we have studied in our properties of rational number that if you are multiplying the denominator by a particular number, you have to multiply the numerator also by the same number so that the value of the fraction will not change, isn't it? That's why here if you want to, as we need to multiply the denominator by minus 6, you will have to multiply the numerator also by minus 6 itself. So next step we will write like this. Minus 3 by 5 is equal to minus 3 by 5 in the numerator part, minus 3 into 6. Minus 3 into minus 6, right? Minus 3 into minus 6 divided by, what is the denominator there? 5. 5 into minus 6 means we multiply the numerator and the denominator by minus 6. That's equal to. Now tell me, in the numerator part you can see what is there in the numerator part. It is minus 3 into minus 6. Minus into minus is plus. 3 into 6, it is 18. So you will get 18 divided by, what about the denominator? 5 into minus 6. Minus into plus, it is minus itself. 5 into 6, it is 30. So minus 30. Finally you will get 18 by minus 30. Okay, you got 18 by minus 30. What was the question? You have to make this as another rational number with the denominator minus 30. Now check the denominator. Is it minus 30? Yes, it is. So this is all. Means what is the question given? What should we make? Is it something that we should make for the denominator or we should change for the numerator part? Just focus on the question. Here the question is about the denominator. That's why we were focusing on the denominator. Just imagine if the same question came that you have to make some changes on the numerator. Means change this number so that 18 will become the numerator. So at that time we will think that by what number should we multiply the numerator part so that it will become 18. Here in this question it was about denominator. That's why we initially went behind denominator. By what number should we multiply the denominator so that it will become minus 30? We thought like that. Clear? First of all, get that number, and with that same number you have to multiply the numerator part and the denominator part. That's the way. Hope you understood. So there are another more questions in the same category. 3 more questions. You can do it by yourself and try it by yourself. If you're not getting the answer, below this video the notes is provided for you. You can just go through the notes and understand how you got it. Is that clear? Main question number 2. Express minus 42 divided by 98 as a rational number with denominator 7. Okay, listen, this is another category. Here a rational number is given. What is the rational number given? It is minus 42 divided by 98. Minus 42 divided by 98. You have to make this into another rational number so that the denominator will become 7. Now tell me, here it is 98, right? Here it is 98, and you have to make this into 7. In the previous question, what was the denominator? The denominator was 5, and you have to make it to minus 30. So that you are thinking of multiplying. By which number should it be multiplied to get 30? That was the thing which we were thinking about. But here you can see that the denominator is a smaller number. It's not 30, right? There it was 5 and you should make it into 30. But here it is 98 and you have to make it into 7. So actually what we have to think, if you are multiplying 98 by any number, definitely it is not going to become 7, right? Because 98 is already bigger number. And if you want to change the 98 to 7, that is the question. So if you want to change this 98 to 7, we can't multiply, because 98, when it is multiplied one time itself, it is 98, right? So at the time it is not about multiplication, actually it is about division. So hope you understood. By which number should be 98 divided so that it will become 7? It's not that much easy, because in the tables which we have studied, 98 is not a common number which we have studied, right? So I will tell you an easier method. First of all, divide this 98 by 7 itself. Divide this 98 by 7 on the working column. While dividing this 98 by 7, you will get it as 14. So that means if you are dividing 98 by 14, definitely the denominator will become 7. Is that clear? So 98 should be divided by 14 so that the denominator will become 7. So if you are dividing the denominator by 14, what should we do with the numerator? We should do the same with the numerator. That means we should divide the numerator also by this same 14 itself. So let us go to the next step. Minus 42 divided by 98 is equal to minus 42 divided by 14 divided by 98 divided by 14. Both the numerator and denominator we are dividing by 14 itself. That's equal to, now tell me, minus 42 divided by 14, that is equal to, that is minus 3, because minus and plus it will become minus itself. So it is minus 3 divided by, what about here? It is 7. So you got minus 3 by 7. What was the question? The denominator should become 7. Yes, we made it as the 7 itself. We made it as 7 itself, right? This is the way how to understand a question, whether we have to divide or we have to multiply. Is that clear? So like this, you can do the main question number 3. There are some questions given there. You can try the same method. Using the same method, you can solve the problems. Try it for yourself. Main question number 4. Express the following in the standard form of rational numbers. Means, what is the standard form of rational numbers? Both the numbers should become co-prime. Both of them should be co-prime. That means there should be no other common factors other than 1. There should be only one common factor, that should be 1 itself. Right? Second thing, the numerator and the denominator, when you are taking numerator and denominator, if in any case, if you are seeing any negative, any minus sign on the denominator, you have to bring it on the numerator. You have to bring it on the numerator means, actually the fact is that you have to multiply the numerator and denominator by minus 1 so that the numerator will become minus and the denominator will become positive. That means we cannot keep a negative number on the denominator part. Okay, we have to bring it on the numerator. Whenever you are seeing a denominator in a negative number, you have to bring the negative sign on the numerator part. Actually, what is the reason behind that? Means when we are doing something, there should be a reason, right? What is the problem if the denominator became negative? See, actually, what is the meaning of a denominator? It's a part, right? It's a part. I told you in the initial video of this chapter, I told you fraction means you are taking a whole and you are cutting it. Into how many pieces you are cutting, that should be the denominator part. If you got a cake, and can you say anybody, I want minus 5 part, just cut it into minus 5 part. Can you say like that? No. You can say cut it into 5 equal parts. Right? You can say like that. You can never say that cut it into minus 2 parts. You can't say. You can't do it also. And another thing, whenever a denominator is there, it means that you have to divide it with the numerator, right? 7 by 2 means 7 divided by 2. That means the multiplication table of 2 you already know, and you are dividing it by 7. Have you ever studied the multiplication table of a negative number? No. So we can conclude that the denominator should never become a negative number. Is that clear? Okay, so this is the way how to bring it to a standard form. So let us check out our question and let us bring it. If it is not in the standard form, let us make it into the standard form. Clear? Here there are 4 questions And in this section there are 4 questions. Let us take one of the question among them. Let us take it. 24 divided by minus 64. Okay, 24 divided by minus 64. Is it in the standard form? No. Why? Because you can see the denominator is negative. So that is not in the set. Let us make it into positive. If you want to make this denominator to positive, you have to multiply the numerator and denominator by minus 1, so that the denominator will become positive and the numerator will become negative. So multiplying the numerator and denominator by minus 1, what will this become? It will change into minus 24 divided by 64. That means now the denominator is positive. Now that much part is okay. Now the second condition, let us check the second condition. What is it? Are they coprimes? No. Why? Because 24 and 64, both of them are in the table of 2, right? That means there is a common factor 2. Again, we can say both of them are there in the table of 4. We can see this 24 and 64 that belongs to the table of 4. That means 4 is also a common factor. So that means, see, more than one common factors are there. So they are not coprimes. They are not coprimes. So make it into coprimes. So actually here you can divide the numerator and denominator by 2 because it's already divisible by 2. You can also divide the numerator and denominator by 4 also because it's also divisible by 4. What is the standard method? You have to make into the simplest form. The easiest method how to make them into simplest form is like this. Check the numerator and check the denominator. Which is the biggest factor? Which is the highest common factor of these two numbers? Find it. What about 24 and 64? Just by analyzing you can understand 8 is the common factor. 8 is the highest common factor, or it is the HCF, right? 8 will be the HCF. 8 is the highest common factor of 24 and 64. So let us straightforward, let us divide the numerator and the denominator by 8 itself. So next step, 24 minus 24 divided by 8 divided by here 64 divided by 8, that's equal to minus 24 divided by 8, it is minus 3. Minus 3 divided by 64 divided by 8, what is it? It is 8. So minus 3 by 8. Now tell me, are they coprimes? Yes, they are. 3 and 8, they doesn't belongs to any of the common table, right? So they are coprimes. So we can say this is in the standard form. So you have to check all these things when you are bringing any particular number to a standard form of the rational numbers. Hope you understood. Main question number 5. Which of the two rational numbers is greater in the given pair? So which of the two rational numbers is greater in the given pair? So there are plenty of pairs given here. Let us choose one of the question. 2 by 3 or 3 by 4. What is our question? We have to check whether 2 by 3 is greater or 3 by 4 is greater. How can we check? If in this both of these rational numbers, if the denominator were same, then it was very easy just to check the numerator part. And which is the highest numerator, that will be the biggest number. Which is the smallest numerator, that will be the smallest number. But here you can see that the denominators are not equal. So it is not that much easy to come to a conclusion that which is bigger one, which is smaller one. Now, when the denominators are not equal, when you are getting different denominators, what you have to do means you have to find the LCM of the denominator. Here the denominators are 3 and 4. So the LCM of 3 and 4 is 12. You got the LCM as 12. Now what is the next step? The next step means you have to change these two fractions or these two rational numbers in such a way that the denominator should become this 12. Which 12? The LCM 12. It should become, the LCM should become equal to the denominator. So let us choose the first rational number. What is the first rational number? It is 2 by 3. So 3 is the denominator. So by which number should 3 be multiplied so that 3 will become 12? It's 4. So that means you have to multiply the numerator and the denominator by this 4 itself. Multiplying the numerator and denominator by 4, you will get it 2 by 3 is equal to 2 into 4 divided by 3 into 4. 2 into 4 it is 8 and 3 into 4 is 12. So you got 8 by 12. Take the second rational number. It is 3 by 4, right? So the denominator here is 4. So by which number we should multiply 4 so that it will become 12? It is 3. 4 3s are 12. So if you are multiplying denominator by 3, numerator also should be multiplied by the same number 3 itself. So here what is the numerator? It is 3. So 3 into 3 divided by 4 into 3, that's equal to 9 by 12. So you got 8 by 12 and 9 by 12. Now both of them are having the same denominators, 8 by 12, 9 by 12. Now tell me, which is bigger one? 9 by 12 is bigger and 8 by 12 is smaller. So we will write 9 by 12 is greater than 8 by 12, right? But our question is not about 9 by 12 and 8 by 12. Let us come back. What is actually 9 by 12? What is actually 9 by 12? It is 3 by 4 itself. So we will write that is 3 by 4 is greater than 2 by 3. So like this, we have to compare whether the numbers are bigger or smaller like this. So the next exercise also you can do like this. Just check out, even here we took only 2 numbers. You can take 3 or 4 numbers, it doesn't matter. If there are 4 numbers also, you can do the same thing. The only thing which you have to think in your mind that take the LCM of all the denominators and convert each fraction in such a way that every denominators will be equal to the received LCM. Whatever LCM you are getting, you have to convert the each fractions to that same LCM. The denominator should become the same. After making the same denominator, then compare the numerators and which is greater, tell that will be the greater one. You can make this in ascending order, you can change them in descending order, like that questions are there, you can do it for yourself. Is that clear? This is the idea behind how to understand which fraction is bigger, which fraction is smaller. Let us come to the last question, main question number 10. Here we have to state whether the given sentences are true or false. That's all. Sentence number 1. What is the statement number 1? Every whole number is a rational number. Every whole number. Whole number starts from 0. Right? 0, 1, 2, 3. 1, 2, 3, 4, 5, 6. All those numbers are rational numbers itself. Right? Why? Because 1 can be written as 1 by 1. 2 can be written as 2 by 1. 3 can be written as 3 by 1. 4 can be expressed as 4 by 1. So we can say that all those numbers are rational. What about 0? 0 can be also written as 0 by 1, right? Yeah. So definitely we can say this statement is right. It's true. Every whole number can be represented as rational numbers. Statement number 2, second statement. Every integer is a rational number. Every integer. Integer means positive numbers, negative numbers including 0. Right now we told about whole number. Whole number means 0 and all the positive integers, right? All together we can say they are whole numbers, right? So leave that part. Let us talk about the negative numbers. Okay, what about the negative numbers? Minus 1. Can minus 1 be represented as a rational number? Minus 1 by 1. Yes. What about minus 2? Minus 2 by 1. Yes. That means each and every integer can be represented as the form p by q. Every integer can be represented in the form p by q. That means numerator divided by denominator. That means this statement is also true. Statement number 3. 0 is a whole number, but it is not a rational number. 0 is a whole number. Is that correct? Yes, it is. 0 is a whole number. That's true. But it is not a rational number. That's the statement given here. It is not a rational number. It is not a rational number. Is 0 a rational number? Or can you express 0 as a rational number? Yes, right now we just discussed about that one, right? 0 can be written as 0 divided by 1. So 0 also is a rational number. So this statement is wrong because this statement says that 0 is not a rational number. But we know the fact that 0 is a rational number. So this statement is false. Hope you understood. So this is all about today's class. Hope you enjoyed the video. So meet you in the next section. Till then, take care and goodbye.